In this problem here, we want to determine whether this function right here, linear function, is one-to-one using the definition. All right, now first of all, we know it's one-to-one because it is linear. And if it's a line, a straight line, it can, as you look left to right, it always rises. It never comes back on itself. It never turns around. It always rises. So we know it's going to be one-to-one, but we want to use the definition. Now here's the definition. It says a function is one-to-one if different inputs have different outputs. All right, so every time you put something in, you get some number. If you put something else in, you get a different number. It means like this. Here's one that is not one-to-one. Let me give you a picture of this. Here's a little graph here. Here's a function of a quadratic. Now what if I put in that a, right? If this is a and that's b, and then what happens if we put in c? Well, we would still get b. So f of a is equal to f of c, and a is not equal to c. Now that's a lot of words, but it just means this. It means if I put in different values, I get the same value back. If I put in different inputs, I get the same output. This is equal to b. Now the function being one-to-one means this. If you put in different inputs, you have to get different outputs. Now here's one where I put in different inputs, but I get the same output. So this is not one-to-one. And you can see that if you get the output b, that can be produced by two different inputs. So here's how I'm going to prove this. I've got this function here, f of x equals 1/7 x minus 2. So choose an a, x equals a, and an x equals b, where a is not equal to b. All right, just two different values for x. So first of all, I'll do it up here on the top right. What is f of a? F of a is going to be 1/7 a minus 2. What is f of b? B is going to be 1/7 b minus 2. Now, I'm going to set these equal. And I'm going to set them equal because this other part of the definition says this. A function is one-to-one if when the inputs are the same, if when the outputs are the same, the inputs are the same. So set f of a and f of b, the outputs, like this one right here, then a has to equal b. All right, so set these two equal to each other. So f of a equals f of b means that 1/7 a, that's supposed to be 1/7. 1/7 a minus 2 must equal 1/7 b minus 2. All right, let's add 2 to each side. So that'll give us 1/7 a equals 1/7 b. Okay, multiply by 7 to get rid of those fractions, and we'll get a equals b. So according to the definition, now the definition says this. If f of a equals f of b, which we did up here, right, f of a equals f of b, that means that a has to equal b. And sure enough, that's what we developed. All right, so using this function, we've now proven that it is one-to-one. Now, number 6, what I want to do is I want to prove that this function here is not one-to-one, right? Prove that g is not one-to-one, but I want to use the definition. Now, I'm just going to go down to this part right here. It says if two outputs are equal, then the inputs have to be the same, which means this, that if I pick the same inputs, I have to get the same outputs. Or the top part says that if I pick different inputs, then I get different outputs. So here's my function. I've got f of x equaling 14 minus x squared. Now, first of all, what if x is equal to, let's try 1, and then let's try -1. So I'm looking at this part up here. If a is not equal to b, all right, now these are my inputs. Okay, remember they're inside, so they're the inputs. So pick two numbers that are not equal to each other. So I'll pick 1 and -1. Now, let's compute. Put 1 and negative 1 into our function right here. So f of 1 is going to be 14 minus 1 squared. That's 14 minus 1, which is 13. And then put in the negative 1. So if I put in negative 1, I get 14 minus negative 1 squared, which is 14 minus 1, negative 1 squared is 1, equals 13. All right, so do you see what's happened here? I have that 1 is not equal to negative 1, but what I get is that f of 1 is equal to f of negative 1, meaning that two different inputs give us the same output. Now what this tells us is that it is a function because one input goes to exactly one output, but one output I can get using two different inputs, right? I can get 13 using x equals 1 and negative 1. All right, what do you think? Using the horizontal line test, is this function right over here in the picture? Here's our graph. Is this one-to-one? Well, look, I'm going to tell you it's one-to-one right by looking at this. As long as I start at any point on the left and I start moving to the right, this function always goes up. It doesn't turn around. If it turned around, it would not be one-to-one, right? I'll draw a little picture here and then I'll erase it. If it turned around like this, then if I pick that output, I could get that using two inputs, right? So one output would come from two inputs, not one-to-one. So let's get rid of that. And I'm going to say it's one-to-one because it's always increasing. But what I want to do is use the horizontal line test. Now the horizontal line test goes like this. If you draw a horizontal line anywhere, like here, does it intercept it no more than one time? This line that I drew intercepts just once. This line intercepts only once. This line intercepts only once. In fact, no matter where I draw a horizontal line, it will not intercept it more than one time. So I'm going to say yes, by the horizontal line test, this function is one-to-one. If I was to do this, turn that function around, then it would not be one-to-one because the horizontal line would intercept that curve in 2 points, meaning that that output can be produced by more than one input. Interesting function in number 8, it's a rational function. What do you think? Is it one-to-one? Use the horizontal line test. So just imagine drawing a horizontal line anywhere, right? Down here, up here, all right? Is it one-to-one? Well, what do you think? It's going to be one-to-one if a horizontal line intercepts that curve no more than once. But up here, in the top one, that horizontal line here, it intercepts right here and right here. So this is not one-to-one. So I'm going to say no, this is not one-to-one because that output right here, whatever that output is, I can produce that using two different inputs. So it's not one-to-one. One input gives me one output comes from one input. And now in number 9, what do you think about this function? Take a look at the graph. Looks to me as I go from left to right, it's always increasing. It never comes back on itself. So by a horizontal line test, or any horizontal line you draw will intercept this curve in only one place. So I'm going to say yes, this function is one-to-one.